All right. I used to. I can't hear you. Can you talk?
Yeah, can you hear me?
Oh yeah. I just got to switch your audio over to the built-in. Oh, we're not plugged into the built-in output. Where did it go? All right, say something now.
Okay, cool. Can you hear me?
Yep. So let me switch this camera over, and we'll slice this video stuff together.
Okay. So so before we start this program, I'm just going to talk about the code a little bit, since I'm sure that facial recognition and tracking with a drone using Go sounds really interesting. So, is it magic? No, it's all Go. So, can you guys see this? Is this large enough? Or actually, I got to share my screen. Sorry. Let me get this. Okay, can you guys see this?
Does everybody sound like Hillary Clinton?
Can you guys see my
Take it at your own risk. You gotta work this out.
All right, Adrian, you there?
Yeah, can you hear me?
Yeah, we can hear you.
Okay, can you guys see my screen?
Yep.
Okay, cool. So, let's go over this program really quick. So, in this program, we're using the AR drone and OpenCV packages. So this one's a little different because I'm setting the Go Max procs, which you guys may or may not have seen this before, but so you've heard that Go is a concurrent language, but Go a lot of times will not will only run on one CPU, logical CPU in your system. So so it will not parallelly execute Go threads by default. It would just, Rob Pike has a good talk about concurrency and parallelism. So if you haven't seen it before, this runtime Go Max procs is how you enable more cores in your application so that they actually start working in parallel. So OpenCV is a little taxing on the system. So, the more cores we have, the better. So for this example, we're bringing in this har cascade file, which a har cascade file basically tells OpenCV what a face looks like. We're setting up a new OpenCV window driver, a new camera instance, which this is the drone's IP address, which since we had to change the Hangout stuff around, it's because the drone actually acts as a Wi-Fi hotspot. So you connect your laptop to the drone to control it. So then here we set up a new drone adapter and drone driver. So here's the work that we're doing. So the first thing we're doing is it's not detecting. We take off the drone. We tell the drone to take off. And when we have another evented on function here, that whenever a new frame comes through, we're going to show the image when the program is detecting a face. So then after the drone's taken off, it has this flying event. So that lets us know when the drone's actually in the air. So then after 1 second, we're going to tell the drone to go up 0.2 speed. And after 2 seconds after that, we're going to tell it to hover. So it's going to shoot up to about face level. So then after 5 seconds, it's going to start detecting. And every 300 milliseconds, we're going to tell the drone to start doing the facial recognition. So this is actually a pretty simple function that, we're going to tell the drone to hover. We're going to detect the faces. This little code here just picks out the largest face of all the faces that we find. So OpenCV will detect multiple faces concurrently, so we want to just find the biggest face. So if there is a face, we're going to draw a rectangle around that face on the screen so you can see that something's being detected. we're going to do a little math here to turn the center of the image. We're going to mount the, kind of overlay the image with the drone's orientation to figure out the center of the image and the center of the drone, figure out the delta between those two, and tell the drone to turn in that direction so that it will make Bill's face the center of its attention. And then after this, we show the image. After 20 seconds, we tell the drone to land. And down here, we have the normal adding the code or adding the robot to the GoBot instance and telling it to start. So might seem like a lot, but in less than 100 lines of code, you can get facial recognition and tracking with an AR drone. So without further ado, I'll hand it off to you, Bill.
It's going to work with camera here so you can see it. I'm going to switch the camera over. All right, I'm going to turn the program on. Let me try this yesterday. See?
Is it tracking you? Let's see. Just gonna shift side to side a little bit.
Shift side to side.
Is it? Oh, I think it's too close to you. Can you tilt it a little bit? I think that. Oh, there it goes. Is it? Step back a little bit. Let's see if it'll track you. It's loving that wall.
Let's stick your finger in. No, I heard right through the You see video on it? How come I don't have a picture on the laptop?
So, it might, I don't know. It seems like something's not working quite right with it right now.
I've done it.
So if you grab it from the bottom, yeah, and then just tilt it upside down. Okay, cool. So that little trick, if you guys have ever used an AR drone, if you flip it upside down, that turns the props off and saves your fingertips. So, yeah. I've spilled much blood over AR drone props.
I did have the OpenCV program that worked off of my... Yesterday, I ran the OpenCV program and popped up on the window that time. So we got to work on it. But very cool. At least it didn't hurt me this time.
Yeah, that's always, it's not a meetup with hardware until someone gets hurt, though.
Switch back over because everybody has questions now they want to ask you.
Sure. Let me turn this off here. Okay, cool. Can you guys see me?
Well, great, guys. So that's the demo. It shows you how cool these GoBot, all the engineering that Adrian has done to just within 10 to 20, 30 lines of code, you can start playing with all of these robotics. And there's lots of other devices they have support for. You go to the GoBot.io website, you'll see that. And I just thought this really probably now on my program. Is there an on-off button here, or you just have to pull the battery out?
Yeah, you can just pull the battery out, and that's what turns it off.
Okay. So, anybody has questions? This is a good time to. You have a question? Yeah.
It's a little hard to hear you, sorry.
I'm all the way up there, so you can
hear me now?
Yeah.
MSP430 to the TI devices. Have you tried using this yet?
So any of the TI devices? Yeah, so if it can run an operating system, then we can run on that. So the BeagleBone Black runs a TI chipset, but as long as it has an embedded Linux, it can use GoBot or some type of remote serial interface like Firmata or LittleWire, or there's some other ones like that. So due to limitations in the Go language, you can't run bare metal or in an RTOS, a real-time operating system. So there are some limitations with that. So you can run on small embedded devices though, like the AR drone, for instance. That's actually a full Linux computer, and you can run GoBot programs on the drone itself to control the drone from inside. But as far as just TI chipsets, if it doesn't have an operating system on it, you can't run on it itself.
Well, you usually like do that.
Yeah, so that uses a remote serial interface called Fermata, which Fermata is a C program that runs on the Arduino. It's a remote serial interface. So what happens is I send and receive payloads, byte payloads to and from the Arduino to control and read the pins. So in the instance of when I was showing that blinking light example, I had it plugged in via a USB cable to my laptop. But if your Arduino has a Bluetooth shield or a Wi-Fi shield or a Zigbee radio or something of that sort, you can remotely control it via Fermata. But Go does not run directly on the Arduino itself, because really nothing can run on there except for the C wire library that Arduino has.
Well, I was actually kind of curious if there's a Fermata.
I'm sorry, can you say that again?
Is there a Fermata for the 430 devices? TI 430s.
Oh, well, so some devices, they will implement Fermata. So, for your specific platform, you'll have to see if somebody implemented that for your platform. But a lot of people implement Fermata on different platforms because, they start out with an Arduino, but they need more power or something like that. So then they switch over to these new platforms, and then they'll write a Fermata compatible library for that. So you'll just have to see about your specific chipset and hardware platform if someone has done that. So there are a lot of Fermata libraries out there that people have written for different types of platforms. And Fermata itself is just an open protocol. So they have a GitHub page that details the entire protocol, how you do it and everything. So, it's really open, and people have done that on different platforms. So you'll just have to see about the specific platform that you have for that. I hope that answers your question.
Yeah.
Anybody else have any questions for Adrian? So I was telling them before about the Go for Slack group we have. Adrian's in that Slack group. So if you want to start playing, Adrian's always available for questions and help when he's not in meetings like the rest of us. But
Yeah.
Adrian is great person in the community. He's out there to help everybody. So start buying some stuff, start playing with GoBot, and there's a lot of help out there.
Yeah, and thanks. And I would also like to mention too that GoBot also has an IRC channel and Twitter and mailing list and all that sort of stuff. So if you guys start playing around with it, feel free to reach out on that. So I'm around and answer questions and all that sort of things. I won't go into too much detail about it here, but a big question that a lot of people have is, how do you actually test physical hardware devices, the code for that? Because you think that you're communicating to a physical hardware device, so how do you actually mock that out in Go? Because Go is not as easy to mock things out as a dynamic language like Ruby or JavaScript or whatever. So GoBot has a pretty high coverage rating. It's over 80% coverage for the entire project. So if you're more curious about that, I have full tests for a lot of different things in there, and how I mock things out using a lot of the built-in Go interfaces and utilizing those to my advantage for mocking out file systems and that sort of things. So, that's something that I know that usually a lot of people they may not ask, but they're thinking that in their head. So that's something that you guys can check out if you're interested in that.
Awesome. Hey, and so Ron Evans is his partner out on the road, and if you guys can ever catch them at a conference, they do some really amazing demos up on stage. Where's the next few conferences you're going to be at?
So we're actually speaking at Fluent which I know that you're going to be there, Bill. So we're speaking at Fluent, and I think that we're in the process of setting up a hardware hacking session at GopherCon this year. And we're also going to be at OSCON and a few other conferences coming up. So we're usually around at different conferences and either speaking or running workshops or something like that. So if you're going to be at GopherCon, then you'll for sure see us there.
And at Fluent, you're not showing the Go stuff, you're showing the JavaScript stuff, right?
Yeah, so for that, we're going to show Cylon.js, which is sort of our sister project. It's written in JavaScript. It runs on Node and in the browser and Chrome apps, all that sort of stuff. And we actually just released Cylon 1.0 last week, and which was really exciting. And we've been working on that a long time. So at Fluent, we're going to do a combination of GoBot and Cylon. So that'll be, multiple hardware platforms and software platforms communicating with each other at the same time to do an overly convoluted and exciting hardware demo live.
And it will be my luck that you're doing that at the same time I'm doing my workshop, right?
I think that we're doing it on the second day of the conference.
Oh, no, I'm leaving on Tuesday. All right.
Oh.
Yeah, we'll talk more then. All right, so
Okay.
thanks, man. I really appreciate it.
Yeah, thanks for having me, guys.
All right, I'll touch base with you later. I really appreciate your time. It was awesome.
Yeah, thanks for having me.
All right, bye.
Okay, see you guys.